Welcome to today's lesson where I'll be learning about continental drift theorem. This theory tries to give an explanation to what happened for us to have different continents as we are having now. Now we are having continents like Africa, North America, South America. We have Australia, just to mention a few. So this show now tries to give an explanation to why we are having these different continents. Why not just having one continent? So at the end of the lesson, should be able to define the term theory and continental drift. Should be able to discuss continental drift theory. Should be able to give evidence supporting continental drift theory. Should be able to give account to weaknesses of continental drift theory. When we say theory, we mean the assumptions which are used to explain facts or events. And the continental drift is a set of ideas that explain how continents move or shift from one position to another. Continental drift is just the movement of continental landmasses apart. And this movement is caused by convectional current in the mantle. There was once a German geoscientist by the name Alfred Wenger, which proposed this theory. This guy proposed that the Earth was once a supercontinent, just one landmass, and he was known by the name Pangaea, that one landmass. And this landmass was surrounded by one super ocean called Pafalancha. I'm not good in pronouncing, so I'm sorry for that. Yeah, so I was saying this one landmass was surrounded by a super ocean called Pafalancha, which means in those times there wasn't different oceans as we know today. Today we have Indian Ocean, we have Pacific Oceans, we have different oceans. So in those days, there was just one ocean called Pafalancha, and there was just one landmass called Pangaea. Now, as time passes, this one landmass, Pangaea now, broke apart into northern landmass and the southern landmass. And this northern landmass is called Laurentian, while southern landmass is called Gondwanaland. This guy also proposed that later on, the northern part, which is Laurentia, broke into other parts, making Northern America continent, making Europe continent, making Asia continent. While Gondwanaland now broke into South America, Africa, Madagascar, India, Australia, and Atlantica. But I said we define theory as a set of assumptions explaining facts or events. So whatever we are learning, they're just assumptions. And no one was there witnessing Gondwanaland break down into two parts. No one was there witnessing Laurentia or Pangaea broke down into different continents. Even himself, this German geoscientist Alfred Wenger wasn't there. So what we are learning is just the assumptions, which may be true or may not be true. So what are the strengths now for this for this theory? One of the strengths is that southern continents fit into a gigantic jigsaw puzzle. If you push them together, they can fit into this gigantic jigsaw puzzle, like South America and Africa. If you can push them together, they can fit into a certain shape. And also, there is identical geological sequence of rocks layer in South America and the Atlantica. And there's also this evidence of the rocks of Brazil and West Africa are similar in age and structure, which shows that the two parts were once joined. There's also rocks in Argentina and South Africa, which are similar in age and structure. And also, we have similarities in plants and animal fossils in different continents, which support that these parts were once joined. And also, there's this evidence which says that fossilized trees in Atlantic continents show that the landmass may have experienced climatic conditions different from those of today. In Atlantica, you can't find trees. The temperature there can't support growth of trees. But the geologists have found fossilized trees there. So where did these trees come from? Obviously, the landmass which make Atlantica was once in a region where the temperature was good enough for the trees to grow. Due to drifting now, it drifted until it is where it is now. And also there's the glacial deposit in Congo. This glacial deposit is impossible because in Congo temperature they're so high, so you can't have glacial deposit there. This also indicates that this landmass was once somewhere and it drifted to where it is now. And there's magnetic ocean rocks evidence which say that these magnets, they orient themselves in a similar way, or they have same magnetic field. Different rocks of different continents, they have similar magnetic field, which indicates that these rocks were once in one area and they drifted because of this contrarial drifting field. So what are the weaknesses now? This field one of the supporting point for the theory said that the other continents can fit into this puzzle, but northern continents like North America, Asia, Greenland, Europe can't fit into this puzzle. So what can you explain about that? Can you say they are once together while they can't fit into this puzzle? So this is just one weakness. And another weakness is that this theory doesn't explain the cause of drifting of the continents. Of course, the guys who proposed this said that the forces responsible for moving was the gravitational force and the centrifugal force. But the careful calculations found that these forces, they are too small to move the continents. And the glacial deposits we were saying they are in Atlantica, they may be there due to ocean currents. Carrying these fossils somewhere and deposit them there. Not necessarily the land masses moving themselves. And there's quite significant body of pathological data suggests that the continents have never moved. So this marks the end of our lesson. Next lesson, we'll look into tectonic theory. So thank you for watching.